Now time for the last part of operations with complex numbers, and that has to do with division. And save that one for last because it's got the most steps involved. It's not harder, it's just that you have more steps to remember and follow through on. Not necessarily remember, but actually work through. So what we end up doing is we multiply the numerator and denominator by the complex conjugate of the denominator. This is called rationalizing the denominator is what we're working on. Excuse me. And so remember our complex conjugate is just the complex number, but the sign, the operation is changed in between the real and the imaginary part. So example 1, 18 plus 9i divided by negative I. Well, I have a negative I, so its complex conjugate would be I. So I multiply top and bottom by I. And then I simplify while I distribute. So 18 times I is 18i, 9i times I is 9i squared. There we go. And the negative I times I is negative I squared on the bottom. Then we've got 9i squared. Well, that's 9 times negative 1. Negative I squared is negative of a negative 1. And so that gets us 18i and then negative 9 and 1 on the bottom. And if I put that in simplest terms, it's just going to be negative 9 plus 18i because we simplify. On example 2, our denominator is negative 1 plus 6i, so its complex conjugate is negative 1 minus 6i. So we multiply that top and bottom. And we have to FOIL, or distributive property. So let's see, 5 times negative 1 is negative 5. 5 times negative 6 is negative 30i. Negative 2i times negative 1 is plus 2i. Negative 2i times negative 6i is positive 12i squared. On the bottom, we're going to have positive 1 plus 6i, then minus 6i, and then minus 36i squared. Anytime we have a I squared, that's going to turn the sign of that to the opposite. So that's going to be minus 12 on top and plus 36 on the bottom. On the bottom, the 6i and the minus 6i cancel. And also on the top, negative 30i plus 2i is negative 28i. So negative 5 minus 12 is going to be negative 17. And then we have the negative 28. And 1 plus 36 is 37. We can't simplify because 17, 28, and 37 do not have any like common factors. Now let's try that again with 18 and 19, and then you're going to try on 20 and 21 on your own. So let's see, 18, the complex conjugate of the denominator is 3 minus 6i. So we multiply that top and bottom. And then let's see, 2i times 3 is 6i. 2i times minus 6i is minus 12i squared. On the bottom, we are going to have 9 minus 18i plus 18i minus 36i squared. Take a moment to get that written down. And then we have to simplify from there. So the top, that's going to be 6i minus 12 times negative 1. On the bottom, the middles cancel. We're always going to do that. And then, so that's going to be 9 minus 36 times negative 1. So that's 6i plus 12 on top, 9 plus 36 on the bottom. That gets us 6i, 12 plus 6i over 45. All of those are divisible by 3, so we do that. And that gets us 4 plus 2i on top over 15, and we are done. Now on the next one, our denominator is 1 minus I, so our complex conjugate is 1 plus I that we multiply the top and bottom by. Excuse me. And on top, that's going to be 2 plus 2I, I plus I squared, and on the bottom, 1 plus I minus I squared. The I squared is turned into -1, so that top is going to be 2 plus 3I minus 1. The bottom is going to be 1 plus 1. Let's see, 2 minus 1 is 1. 1 plus 1 is 2, so that just simplifies to 1 plus 3I over 2. And that's as much as we can simplify. Now, go ahead and try 20 and 21 on your own, and then, so pause the video and then come back and check that after you've tried them. Okay, you should have tried those. Let's take a look. 3 plus 5I for the denominator on 20. That would be complex conjugate would be 3 minus 5I that we multiply the top and bottom by. And then, let's see. So negative 6I plus 10I squared on top. 9 minus 15I plus 15I minus 25I squared. I squareds get replaced with -1, and so that gets us negative 6I minus 10 over 9 plus 25. Let's see, that's going to be negative 10 minus 6I over 34. Divide everybody by 2, gets us negative 5 minus 3I over 17, and we would be done. Yours matched. And now try the 21. It's a positive 2I, so its complex conjugate would be negative 2I. Multiply the top and bottom by that. And that gets us negative 10I minus 2I squared over negative 4I squared. The I squareds turn to negative 1s. And that gets us negative 10I plus 2 over 4. Divide everybody by 2. That, put it in standard form, put the real part up front. So that'd be 1 minus 5I over 2, and we would be done. Now, sometimes we may need to find just solving an equation that's got real parts and imaginary parts, and we're looking for what each of those coefficients happens to be. So 3x minus 5 plus y minus 3i equals 7 plus 6i. So 3x minus 5 should equal 7, and y minus 3 should equal 6. Solve each of those. So add 5 on both sides for the one with x, and that gets us 3x equals 12. Divide both sides by 3. That gets us x equals 4. On the right side, y minus 3 equals 6. We just add 3 to both sides, and y equals 9. So x equals 4 and y equals 9 would be our end results. Now, go ahead and try 23 on your own. Okay, so started the video back up. So 2x plus yi equals negative 14 minus 3i. So 2x should equal negative 14 and y equals negative 3. Right side's done. We know what y is. On the left, 2x equals negative 14. Divide both sides by 2. So x equals negative 7. And we have both of our answers. Now you should be able to do number 8, 11, and 12 on the worksheet to finish it off.